Now, I want to welcome you all to the revision session of the Principles for Food Technology, and I'm going to switch off my video so that it can be clearer. It's not a problem, it can be clearer. I just want to be sure that everything is clearer, and if it is working fine, I will leave it on. But if I discover there's a problem, you not hearing me properly, I can switch it off. But now I can leave it on. I think everything is fine. As far as I could see from here, everything is fine. So what we're going to do today, I'm going to talk about what you need to know about the module, about what is required for the exam. And we're going to start from the beginning to the end. We're going to cover everything. We're going to talk about everything you need to know about the module. And the reason I've chosen this method, using Collaborate, is because it's very easy to record. Now, you remember when I was doing the class version for revision for communication and numeracy, not everybody was around, and I was not happy because I think I was putting some students in a disadvantaged position. And I think the only way out of that is to have a platform such as this, and we can record everything. And I don't mind, I can do another one next week if you want me to do, but I'm sure what you are going to do today will be more than enough for your exam, for your revision, and then plus what you have on Blackboard. I think you should be fine regarding your revision. So what I'm going to be doing now, I'm going to cover everything, and and I want to say thank you very much for giving me the permission to record this, so that people can go by. Even you yourself, you can go over it again and again. And then I'm going to be very slow so that you can follow my calculation and everything. And like I said, if you have any question, you can ask your question by text. You can also ask your question by microphone. Just let me know that you want to ask a question, then I will give you the permission to speak from your end. So what we're going to be doing, we're going to be covering the module, like I said, from the beginning to the end. I'm going to be touching each of those components that we'll cover during the study, during the course of this module, and then starting from the introduction to food technology area that I want you to pay attention to. We also go I know in your assignment you cover this second aspect, preliminary operation. We also talk about this, and we're going to spend a lot of time on dimension quantities, a lot of time on simple steady state overall material balance, and also a lot of time on physical properties. And then finally, we'll be spending some time on elementary flow, which talk about the flow, velocity profile, mean profile. We talk about laminar flow. This is where you need to know about your Reynolds number. So I will now go to the learning outcomes. You know, at the end of this module, this is what we expect you to do. And I'm glad you've all demonstrated this evidence of number one, your module assignment, in your coursework, and you've done very well regarding that. The second aspect is use of physical quantity with confidence. You've demonstrated part of this in your assignment as well. And solving simple problems, you also demonstrated this in your assignment. Determining Reynolds number. Yes, this was not covered in your assignment, but it's done, so you understand what that means. If it is not covered in your assignment and it is something you are supposed to know, you know definitely it's going to come out it's going to be something that we need to address in the exam. So if there's something, and again, like if you have learning outcomes that you've already covered in your module coursework, some of them will be repeated in your exam as well. So it doesn't mean that because you've done it in your assignment, we can't cover it in the exam. No, it doesn't work like that. So just take note of that. All of this, you are required to demonstrate your understanding of all of this in the exam. And I'm going to be helping you, so you don't have to worry, you don't have to fear, you don't have to be afraid. I'm going to, Renata, welcome to the session. I can see you, you just joined us now. We are just starting the session now. I'm just going through the requirements, the module learning outcomes. And something I've asked the students that have joined earlier is permission to record this session. And I just want to check with you that you'll be happy for me to record this session, Renata. You can just type in yes if you want me to record this session. There's a box, it's a very small box underneath the chat that you can simply say yes or no if you want me to record this session. Renata, can you hear me loud and clear? Well, I will be waiting to hear from the leader, but I will go on now. So, like I said, so these are the learning outcomes that I want to take note of, and another thing I think I should let you know is the examination format. I'm going to provide for you formula sheet, and this formula sheet has 15 formulas in total. 15 formula in total. So you have 15 formulas. And I think you will not need more than that. And I've given you this formula on your, oh good, thank you. I've given you this formula on the module Blackboard. So you have the formula sheet on module Blackboard. So you try and familiarize yourself with this formula. It's going to be of help. Familiarize yourself with them. So 15 of them, it's going to be provided for you. And in the exam, is 100%, it's going to be 100 marks, and it's going to be 60%. Your module coursework is 40%. Now, question number 1 is 25 marks. Unlike what happened last year. Last year, question number 1 is 30%. But this time around, question number 1 is going to be 25. Excuse me. Question number 1 is going to be 25 marks. Number 2, 25 marks. Number 3, 30 marks. So, and number 4 is 20 marks. Now, the very first thing, now going to the teaching section 2, teaching section number 2. Now, we talk about the introduction to food technology. Here we talk about the organoleptic characteristics of food. We talk about food safety. We talk about a spoilage concept. And what we want you to know here is to identify major organoleptic characteristics of food and major risks to food safety. You need to know the major risks to food safety. Here, we talk about, we define the properties, the organoleptic properties as measures of responses of people to food as perceived by their senses as a result of the ability of food to stimulate these senses. You know, we have different senses. We have our touch starting from our hand, we have our tongue, we have our eyes as well. So all of these, we use them to assess the food, to assess the properties of the food. And when you bring them together, your taste, your smell, your mouthfeel, the way it appears, the sound, when you bring all of these together, we call them organoleptic properties. Now, and we said that because the result is going to be based on individuals. So we said they are subjective measurements because it's going to be subjective. Whatever I say, okay, it's too hard, it's hard, or it's soft, is subjective. Somebody can say, whatever I said is hard, somebody can say, no, this is soft. So we know there are elements of subjectivity in measuring food properties using our senses. And we said that we can actually reduce variability by training the assessors. So that's everything we cover under organoleptic properties. And we also talk about food spoilage. And there are 4 different ways that we cover that food can be spoiled. We talk about microbial spoilage. We talk about spoilage through enzymes. We talk about chemical changes or contamination or chemical changes or contamination or through. We talk about contamination changes. So that's the problem. I don't agree with that. Maybe something is wrong with that. So we talk about chemical changes. Sorry, I just want to find something. So here I think something is wrong with this. So we talk about we have microbial spoilage. We have spoilage through enzymes. We have spoilage through chemical or through contaminants. So we also have physical change. We also have physical changes, or we can talk about contamination through physical contaminants. So we talk about that. So I want you to pay attention to this one, knowing how our food can be spoiled. Our food can be spoiled via microbial means, can be spoiled via enzyme, can be spoiled via chemicals, or by physical contaminants like debris or packaging materials. So these are physical contaminants. So I want you to take note of that. And another thing we talk about is food safety. And then what we are talking about when we're talking about food safety is all about applying our knowledge to make sure that we prevent any contamination? That is just the whole essence of food safety. How do we prevent contamination? What methods are we going to use to prevent food contamination? So all we need to do is to understand how food is contaminated. When we understand how food is contaminated, then we can design systems to reduce or eliminate the risk. You remember, in food industry, there's so many things we put in place to ensure that we avoid food contamination. We have the cleaning procedures. When visitors are coming to the food factories, there's so many things we put in place that we ensures that we put in place like a barrier to avoid it might look like a barrier, but they are there to avoid food contamination. So these are the theoretical aspects of the module, and we'll be going now on this another theoretical aspect of the module that I think will not be a problem for you is the preliminary operation, which you I understand in your module coursework. You like I mentioned earlier, you've demonstrated this in your module coursework. We talk about why do we have to do preliminary operation? Cleaning, for example, is to remove contaminant. Whatever you want to mention here, cleaning is just to remove contaminants. So, like the assignment I gave to you, this is a generic one. You have the raw material coming in. Then the preliminary operation here is cleaning. Then you have the finished product. What is that product? In the assignment, some of you did something very similar to this in your assignment. But what I want you to do is to give me the name of the product, tell me the name of the finished product, and tell me the foreign matters that you've removed. I want to see that material balance, what goes in and what comes out. So, and some of you lost some marks because you were not specific enough, telling me the materials involved in the preliminary operation. So these are the theoretical aspects of the module. So we'll be going to where I believe you will need my support. So talking about the calculation, the mathematical elements of this module. So we will start with the session number 4, which covers the dimension quantities. Here we are going to be talking about physical quantities. How do we understand the unit? How do we use them correctly with confidence? And then solving simple problems involving velocity, acceleration, and force. So here, the very first thing we discuss under the dimension quantities is the SI unit. And I remember telling us that we have 7 base quantities, and they are length, mass, time, electric current, temperature, amount of substance, and luminous intensity. And I mentioned also that the unit name for length is meter. And then now please take note of this. My meter here is not in capital letter M, it is small letter m. If it is capital letter M, it is something else. So take note of all of this. Now have a look at this, kilogram. Kilogram here, the K here is in small letter and the G here is in small letter. So take note of that. And then for time, seconds, small letter X, and electric current, amperes, Kelvin. Now have a look at this. Kelvin, the unit, the SI unit of temperature is Kelvin, and you can see it's capital letter K. If it is small k, it is something else. So I want you all to take note of this when you're giving me the unit of the parameters you've calculated. Make sure you give me the right unit, because it's important when you communicate to others in the place of work or communicate with your suppliers or your customer in some, maybe you want them to supply something, you want to communicate with them in the language you understand, using the appropriate unit, and that will make sure that your message is clear to your customer or to your suppliers. Now moving forward, we talk about the derived unit. Now this is the second component, the second aspect, the derived unit. We talk about area, for example. Area is the product of length and breadth, and then we know if the unit of length is meter, and then the unit of breadth also is meter. So we know that your area will be length multiplied by breadth. That will be meter square. So meter square, that's the unit of our area. Now for volume is meter in 3 places. 1, 2, 3. So we have meter cube. Density equals mass over volume. Now all of these formulas, some of these formulas, for example, area, volume, density, have been given to you. I'm not expecting you to cram them. I'm not testing how good you are to cram and pour out something from you. No. I want to see your understanding of the concept. I give you a problem. Then I've given you the formula to several formulas. Now I want to see your ability to identify the right formula and apply it and give me the correct answer. Now, density, you know that it's going to be mass over volume. For example, at your place of work, if you want to solve a problem, you could make reference to some materials. You could Google online, search the right formula, and so on and so forth. But in terms of solving the problem you have at hand, you need to understand the problem. And then if you understand the problem, you can say, okay, this is the problem. Then you go for the right formula. Then you give me you give the person at the receiving end the right solution. So density, mass over volume, and you know that your mass is measured in kilogram, and then your volume is measured in cubic meter. So in essence, you need to know the unit names and the unit symbol of the base quantities. If you know all of this, you can derive any unit, because every other unit, they come from the base quantity. So if you understand your base quantity, definitely you can tell me the unit of any parameters, even if it is something Moses is going to derive for himself, or somebody else is deriving for himself or for herself. So you can actually tell the person the unit if you know the base unit. Now, velocity or speed is given as distance over time. We know that our distance is measured in meter and our time is measured in seconds. So the unit of velocity or speed will be meter per seconds. Now, acceleration equals velocity over time. And if we know just now that the unit of velocity is meter per seconds and the time is in seconds, so this will be meter per second square. Now, don't make any mistake here. Velocity is meter per seconds. Second is also added to it, so that will be meter per second square, because seconds is going into the denominator. Do you all get me up to this point? If you all get me up to this point, I want you all to give me a smiley face. Now there's an icon there that shows emotion, and the first one is smiley face. If you all can give me a smiley face, I know you all understand. If you don't understand, you can raise up your hand. You can stop me at any time. Thank you very much. Oh, good. I think Yavenda, you want to ask a question? Do you want to type your question and I read it for the class, or do you want to ask your question verbally? Yavenda, we're listening. I see your hand up. Where do we use? What's the meaning of CD? What's the meaning? I don't understand what you mean by luminous intensity. Now, luminous is for this module. We are not going to cover this. But as you move higher, some of you will be moving from foundation to degree. Some of you want to say, "Oh no, I want to go for a master." Some of you want to say, "I want to go for PhD." That is where we'll be talking about some of these higher units. But for now, yes, you understand your luminous intensity is just talking about it has something to do with measuring the intensity of light or something like that. But we are like more, we partially cover mole in material balance, but we are not going to be focusing more on moles. We are not going to be focusing more on luminous intensity. Now, we just have to know it because it's part of the base quantity. Do you understand that? Good. So this is where we have the pressure. Now I think before the question, velocity over time is our acceleration. Then we have meter per second square. Now force. Now here, please take note of force. Force and weight. You could take them to be the same thing. And force is given as mass multiplied by acceleration. We know that the unit of our mass is kilogram from the previous slide, and we know that the unit of acceleration is meter per second square. So all we just need to do is just to multiply kilogram multiplied by meter per second square. That's the unit. That's the unit. But we know to make things easy for ourselves, there's someone behind that. So, and it's called Newton, Isaac Newton. So we say, okay, the unit of force, let's make it simple for ourselves, it's going to be measured in N, Newton. Same for Pascal, you have the base, the unit, the basic component, and you could equally say it's in Pascal. That in essence, we are saying Pascal is SI unit, we are saying Newton is in SI unit because of the base unit that we have here. The same thing for energy. Energy is measured in joule. But don't forget that our energy can also be described as work, can also be described as quantity of heat, and it's given as force multiplied by distance. When you're talking about work done equals force multiplied by distance. And that tells us that Newton multiplied by meter. Yes, question? Let me see. Okay, Chris, you want to ask a question? Verbally or by text? I'm fine. You're fine.
Hello, Moses. I don't know if you can hear me.
Yeah, I can hear you loud and clear.
Oh, okay. For pressure, it's known as pascals. I've never seen pressure been referred to as pascals. It's always pounds per square inch or so many bar.
Yes. Now that unit you just mentioned is a unit of pressure, but it's not the SI unit. Now there's a conversion from Pascal to PSI. So I think during the study we talked about that. Now the unit of pressure that you know, yes, you're right, is not the SI unit. It's not the system of unit that everyone, all the scientists want to recognize pressure as. So you are very, very correct. But in order to make things easy for ourselves, we want to limit this to SI unit. Does that answer your question? Chris, are you still there?
Yeah, that's fine.
Oh, good. Thank you.
Yeah, that's fine.
Thank you. Just remember, if you want to talk, remember to put on the mic, and if you finish talking, just remember to switch off the mic. Good. So that's for work done. Energy consists of heat is measured in joule, and don't forget that your work done equals force multiplied by distance. And so, looking at the component in it, first Newton, distance is in meter. I'm happy. You can simply put it as joule. I'm fine. You could say, okay, it's Newton meter. I'm fine. But I will not penalize you if you use any of these units. I'm fine with any of them that you are comfortable with. For power, you could simply put watts. I'm fine. You could say, okay, since I want to prove to you that I know more. You can say it's in joule per second. I am very, very fine with that. So whatever unit you want to give me, ensure that you give me the right unit. For example, you cannot tell me that your power is measured in kilogram per meter per second cube. No, it's going to be kilogram per meter square. Sorry, kilogram meter square per second raised to power 3. So you need to make sure that everything is fine, or you simply make it easy for yourself. Power is measured in watts. So all of these are just there for you to understand the basis of all these units. Now going forward, I think it would be nice if you can do some examples. I gave you this as a practice question, and I think some of you have attempted it, which is very great. Some of you have asked me questions on it, which is very, very great. So what am I trying to evaluate here? I've given you x. X is given as vt plus at squared, and I've said here that v equals velocity, t equals time, a equals acceleration, and I ask you to find the units of x and y. Now let me just say something. Now, before I could add Vt and At squared together, they must be in the same unit. It is not possible for me to add £2 and $2 together. If I'm adding them together as they are now, I'm adding them together. If I ask you what is the unit of x, the unit of x is equal to the unit of Vt or the unit of At squared, because you can add them together. If you can add them together, they must have the same unit, or each component must have the same unit. So the unit of Vt must equal to the unit of AT square. If you do this, if you have this type of question in the exam, and you find out that your unit of VT is not equal to unit of AT square, you know that something is wrong somewhere. So your VT must be equal to AT square in terms of unit. They must be the same thing, and you will see as we solve this problem. Let's solve this together. Now we've said that, sorry, these are another questions, but let's have now this is another question. We'll also discuss all of these questions. I gave you all of them for practice, but we'll solve them now. So let's go to the question, to solutions to the question. Now, number one, we have been given this. We want to find the unit of x. Now, the very first thing you want to do is to write the unit of velocity multiplied by the unit of time plus the unit of acceleration multiplied by the unit of time square. Take note, this is time square. Now, let's look at what I've done. So, the unit of s will be unit of velocity, which is meter per second square. Now, multiplied by the unit of time, which is in seconds. You could see that here. Plus the unit of acceleration, meter per second square, multiplied by the unit of time, seconds square. Now let's look at what we have. Meter per second square multiplied by seconds. You could see x here, we cancel this s because this s is in denominator position, and here is in numerator. This figure x the second s is numerator. Is a numerator, and the first one is in denominator position. So, which means this is up top. If you don't understand that time, don't worry. I'm only saying that x is down, this s here is up, so they can cancel themselves. You could see this division. So, we'll be left with m. You could see what we have here. We are left with m, and on the other hand, second square is down, second square is up, so they will cancel out each other. So we are also left with m. You can see that we have the same unit for both quantities. This quantity and this quantity, they have unit of m, and which means that our x will be in meter. So the unit of x would be, the unit of x will be in meter. You can see from what we've done here. Now you don't need to say it's going to be 2m. You don't need to say it's going to be m plus m. It's going to, no. We don't need. We are not adding them together. I'm only asking you what to be the unit, and it's going to be measured in m, in meters. Okay. Now, and if you look at your y, let's look at our y. Our y is Vt over AT square. We've proved that our Vt is m, our AT square is m. M is up, m is down. So when m cancels m, we are left with what? 1. So we are left with 1. So we can equally tell me that our y is going to be dimensionless. So our y has no unit. You remember Reynolds number? Reynolds number, they are numbers that have no unit. They are dimensional. Reynolds number, for example, is a number that has no unit. It's a dimensionless number. Now, because what you have in the denominator dividing what you have in the numerator divided by what you have in the denominator, they have the same unit. So when they have the same unit, numerator, denominator have the same unit, they will cancel out each other, and we are left with 1. So here we know that our y, the unit of y you can simply say it has no unit. Our y is dimensionless. So do you understand that? Do you all understand that? Response, please. Yes. If you all understand, let's start. Yes. Any response from you all? Oh, somebody is confused. Is that Rebecca? Oh, Rick? Okay, I will explain that again. Okay, Maria, I will explain that again. Okay, somebody asked me, okay, Rebecca, are you with me now? Good. So here, okay, I think maybe it might be the network. I'm trying to do that. It might be the network. Is it better now? Can you hear me clearly now? Maria? Oh, good. Okay, maybe Maria, can you hear me? Oh, good. Maybe because of the position of my mic. Now, if you look at this equation 1, I want to find the unit of x for me. Now, if you are looking for unit of x, now the very first thing you would do is to look at what are the components that you have in x. You have vt plus at squared. I explained earlier that if you can add them together, they must be in the same unit. And we said earlier that the unit of v, we've done that. We said in our, let me see if I can find that. Here we've said earlier that our velocity is measured in meter per second. Okay, we have that as meter per second. Acceleration is in meter per second square, and our time, one of the base quantities, is in seconds. So let's go back to the question. The question, we want to find the unit of x. Now, if you want to find the unit of x, all you need to do is to get the individual components, the units of the individual components that makes up x. And then we have v, we have t, we have a, we have t squared. And you know that your unit of v is meter per second. Now let me see if I can do something. Let me see if I can do something here. Okay. Let me see. You know that your sorry. I want to see if I can do something here. Okay, good. You know that you have v t, okay? You know that your unit of velocity is meter all over seconds, okay? And you know that your unit of time is seconds. So your x on the top, we cancel x below, so we are left with m, meter. The other component here for x is a t squared. Now you know that our a is meter per second square. Okay, and our time, don't forget, it's time square. It's not just time, it's time square. It's seconds square. So second square, we cancel second square. So we are left with m. So the unit of v is m. Sorry, the unit of vt is m, and the unit of at square is m. So which implies that our unit of x will be what? M. So our unit of x will be m. Let me see. Yeah, our unit of m will be m. And looking at the second question, we want to find the unit of y, vt over at squared. So vt is measured in m, at squared is measured in m. Let's go back to another. So you know that vt is measured. Remember, vt. Let me see if I can get this back. Okay. So you remember that your vt. Oh, sorry. Let me get. I need to get something clearer. Come on. So we know that our vt is measured in m, and our at squared is measured in m. So m on the top, m below, we cancel m at the top. So we are left with what? 1. So the implication of that is that our y has no unit. Our y is dimensionless. So our y has no unit. Okay, do you understand that? Okay, Simon, I understand you're leaving. That's fine. Thank you. Oh, you've left already. Oh, good, good. Do you all understand that? Wonderful. Thank you. So let's move forward. Now, the second question is, we want to find the area of this parameter. A transfer surface area is 25 by 25. 25 centimeter by 25 centimeter. Calculate value in centimeter square in meter square. This is going to be straightforward. All we need to do is just to take our calculator. 25 centimeter multiplied by 25 centimeter. We get the area in centimeter square. In meter square, don't forget, if you want to do it in meter square, one way of doing it is by converting this one. You can convert this to meter. So if you convert the 25 centimeter to meter, you remember that 100 centimeter makes 1 meter. If 100 centimeter make 1 meter, 100 centimeter make 1 meter, so that shows that 25 centimeter will be 25 divided by 100 will be 0.25. You can see what this means. It's going to be 25 divided by 100. So that's why we have 0.25 meter. Okay, we multiply 0.25 meter by 0.25 meter. Oh, somebody's asking question here. Question one. What's the last question? Does mean oh no, why? It's not really. No. Sorry, Rebecca. When you're asking question, try and raise up your hand so that I can have that info. I can have that alert. If you type in the text, I may not see it. Okay, thank you for understanding me. Thank you. So it's not a problem, but I just want to know. I want to answer your question immediately. That is why I'm asking for that. It doesn't mean why it's not. I just formulated that. It's not why it's not a real number. No, I formulated that question. Okay, so why it doesn't mean why is it? Chris, yes, your question?
Yes, Moses. In the exam, if we're given a question similar to the one that's on the screen and it's in centimeters, is it better for the final result? Is it better to put it into meters?
Yes, I think it's always good to work in meters. In SI unit, for example, which is in this case meter, except you are told to do otherwise. Okay.
Okay, thank you.
Okay. Becky, do you understand that? Renita, okay, no problem, that's fine, Renita. Oh, good, that's fine. So now let's move forward now. Now this is another question. This one is asking us to find the to find the cross-sectional area of a pipe. Now the cross-sectional area of a pipe and area of a circle, you use the same formula. You use the same formula for cross-sectional area of a pipe and area of a circle. So same formula for both. So take note of that. So here we are interested in calculating the cross-sectional area, and we've been given the internal diameter of the pipe. We have the internal diameter of the pipe. Now that's the internal diameter of the pipe, 48 millimeter, and then we want to find the cross-sectional area. And then, like Chris asked the other time. Now here we will not specify whether to find the pipe. Okay. And question from Yavenda. You're typing your question?
No, okay, I'm just asking this time. The formula in the slides which you sent earlier for cross-section is pi times radius square.
Yes,
so
that's
times diameter.
Yeah, they are the same formula. Thank you for that observation. That is good, Yavenda. Now, this formula is the same thing as pi r square. It's the same thing, okay? That formula is the same thing as that. Okay? Does that solve that problem? I can show you that, but I'm just thinking about our time. Okay? Yavenda, is that okay? Oh, good. So they are you can use this If you use any of these two formula, you get any of the two, you get the same answer. So the cross-sectional area is this. All you just need to do, once you know the formula, put the formula down, put the given there, then square divided by 4, then you then square it, then multiply by pi. Pi, you can get that in your calculator, is 22/7. So take note of that. Your pi is 22/7. Then these are just something you could do using your calculator. Do you agree with me? If you have any questions, just let me know by raising up your hand, okay? Now, the next question is, a current source occupies a volume of 0.03 meter cube and has a mass of this. Calculate the density of the liquid in kilogram per meter cube. And D, if your mic is on, please remember to put it off. Yeah, I think it's clear now. Good, that's perfect. Good, thank you. So now we want to calculate the density of the liquid in kilogram per meter cube and in kilogram per liter. I've given you the formula sheet. All you need to do is just to go have a look at the formula of density. What is the formula of density? It's given to us as mass over volume. I don't need to check the formula sheet. It's here already. So that's the unit of density. Now, like I said, the very first thing you want to do is to put down the given volume, mass. Then we want to find the volume in kilogram per meter cube. So we have the mass already given to us in 1,400 grams. So we need to convert that to kilogram. What do we need to do? Is to divide this by 1,000. If you divide this by 1,000, you have it in kilogram. So we have it in kilogram. So the next thing we need to do now is to check our volume. Is it given to us in meter cube? Perfect. It's given to us in meter cube. We do not need to do anything. So all we just need to do is just to divide 1.4 for mass. We've gotten that already. Divide that by volume, which is given to us as 0.03 meter cube. So your calculator will do the rest. Then you have the answer in kilogram per meter cube. Now the next question, which is going to be a bit of a challenge, is to calculate it in kilogram per liters. So we need to do a conversion from meter cube to liters. So let's look at that. So we know that 1 meter cube equals 1,000 liters. I am not going to give you this. You will need to know this. So you know that our 1 meter cube equals 1,000 liters. Therefore, now we are given 0.03 meter cube. So therefore, our 0.03 meter cube will be 30 liters. Now let me show you how this works. Now, if you are moving from one to one, look at what is happening here. From here, from meter cube, from this side, let me change from this side to this side. Look at what we've done. We multiply by 1,000. Can we see that? Can we see that 1 to this is by multiplying by 1,000? So if you are moving from here to here, all we need to do, excuse me. So all we need to do is to multiply by 1,000. So 0.03 multiplied by 1,000 is 30 liters. So from 0.03 meter cube, we go to 30 liters. So we have the answer. We have the volume now in liters. So all we need to do is to divide the mass that we've already converted to kilogram by the volume in liters. So you have the answer in liters. Now let's go back to the next slide, the previous slide. Look at this. Look at this. You know, before, I just want to demonstrate something to you here. We know before that our 1,000 gram equals 1 kilogram. Okay, 1,000 gram equals 1 kilogram. Now look at this. 1,000. Now what have we done? What have we done to this? This is the standard. I expect you to know the standard. What have we done to the standard? We divide by 1,000. So if you are going from 1,400 gram to kilogram, if you are going from 1,400 gram to kilogram, all we need to do is to divide by 1,000. So that is why we have 1.4. I'm just trying to show you how the conversion is done. Okay. All right. Now, if you understand Moses up to this point, can we all put on a smiley face? And if otherwise, maybe a confused face. If you understand me, a smiley face, please. Okay, a question from Rick. Rick, you want to type in your question, or you want to, let me see. Okay, you've already done it. Okay. With the conversion information sheet at the beginning of this, no. Let me see if I understand your question. I will be giving you the formula sheet, not the conversion sheet. I won't be giving you the standard. I won't be giving you the conversion, the standard. I will be giving you the formula. I won't be giving you. Well, I expect you to know. For example, I expect you to know. This. For example, the liter one. I expect you to know the gram to kilogram. I expect you to know the common one that you will need. For example, I expect everybody to know 100 centimeter will be 1 meter. I expect you to know that 1,000 gram will be 1 kilogram. Those one, that's not really a big deal. And I expect you also to know that your 1 meter cube equals 1,000 liters. The one we use here. Your 1 meter cube equals 1,000 liters. So I expect you to know all of this. If you know, it's just knowing them. And once you get to the exam, you can just take your exam question and write it down. Just jot it down on your exam question paper, just so that you don't forget. But one thing I know is this: if you practice with them, you won't forget them. That's what you need. Practice. If you practice, you won't forget. You will remember them. You don't need to stress yourself to remember them. So I will give you the formula sheet, but not the conversion. Okay, Rick. I'm not sure that makes you happy, but I'm sure I've answered your question. Is that okay? Okay, good. Thank you. Now, so that is that one. So please take note of that problem. Another problem that in the practice question, I know some of you have done all of this, so it will not really be a problem. And when you are doing revision, when you want to listen to this video again, you could actually fast forward all of these parts and focus on the area you need most. Now, this is another question. This is given to us a packing case. It's 10 kilograms. And a constant force of 30 Newton is applied to the case. Calculate the acceleration of the case. Now, this is going back to the formula. Now, if you know the formula for acceleration, very simple. If you know the formula for acceleration to be, you know, now this is something that can be confusing. You know that force equals mass multiplied by acceleration. Okay. If you know that your force equals mass multiplied by acceleration, I've given you the force, I have given you the mass, and I want you to calculate the acceleration. All you need to do is to make acceleration the subject of the formula. You don't need to show me how you make A the subject of the formula. No, I don't need to know that. All I want to see is A equals F over M. So your acceleration equals force over M. So from the formula that I've given to you, you can actually make your A the subject of the formula. So if you know that your F equals MA as given to you in the formula sheet, you can actually tell me what your acceleration will be. So your acceleration will be force, which is going to be 30 Newton divided by mass, which is 10 kilograms. So you divide, then 30 divided by 10, that will be 3. Don't forget, it's very important, the unit. You need to tell me the unit. 3 meter per second square. That is the unit of acceleration. You need to tell me that unit. You need to tell me that you know the unit of acceleration. So that's how you will solve that problem. And the second question says, the work done if the force applied to move the case, if the force is applied to move the case by 2 meters. Now, they want us to calculate the work done. Remember, in the formula sheet, work done equals force multiplied by distance. If you remember that your work done equals force multiplied by distance, now you'll be giving the force to be 30 Newton, and the distance covered here is given to us as 2. 30 multiplied by 2 is what? 60 joule. And another question that is they ask us to calculate the power if it took 20 seconds to move the case in such a way. Now they want us to calculate the power. Don't forget that your power is work done over time. It's going to be given to us in the formula as well, in the formula sheet as well. Your power is work done over time. You've calculated the work done here, then you'll be given the time to be 20 seconds. So your work divided by time will give you the power. Now, one thing I want us to know here is that please, if a question, you have this type of question in the exam, for example, you will notice that question B will be right if your answer to question A is right. If your answer to question A is wrong, answer to question B will be wrong, answer to question C will be wrong. So it's always good to make sure that you do it correctly. You get A, you get your B, you get your C. But if you get your A, sorry, if you don't get your A, there's no way you could get your B and C. So please, it pay me, I bleed it give me, I do not like it seeing my students missing all of the questions because they could not pay attention to question number 1. So it grieves my heart. It grieves my heart. So it's always good to pay attention to each of the questions. Do it right. If you do A right, your B will be right, your C will be right, and you get 100%. That is my desire, getting everything. So take note of everything step by step. Don't miss any step. If you miss one step, you may want to use that answer in subsequent questions. So if you get it wrong in the first part, the second part will be wrong. So that is why we need to pay attention. It doesn't really waste, it doesn't really take a lot of time to cross-check. Oh, have I done it right? Because I'm going to use this in B. Oh, have I done B right? Because I'm going to use B. The answer in B is C. So you can quickly cross-check because the answer you get, the first answer will affect a lot of the answer down the line. So it's always good to check that everything is correct. I hope we understand up to that point. So here, the next question here is to find the pressure at the bottom of a large tank. Now this large tank is containing is 25 meters deep, and they want us to calculate the pressure at the bottom of that tank. Now, and we've been told that we should assume that the area of that tank is 1 meter square. That we should use 1 meter square, the length and breadth of that tank. We've been told that we can use that to be 1 meter square, and the density of the water is given to us as 1,000 kilograms. Now here we just have to be very careful in this question. Now I'm handling this question. Now the very first thing I would like to also do here is to have a sketch. If you have a sketch, let's take this is the tank in question. So we've been told that area here is 1 meter by 1 meter. Now at the bottom you could see 1 meter by 1 meter at the bottom here. So we've been told that the length, the height, or whatever, the height of the tank is 25 meters, and we've been told this is 1 by 1, and we want to find the pressure at the bottom of the tank. Now, don't forget, when we started, I said that pressure equals the weight. I'll go back to that slide so that you can understand. Let me see if I can get that fast enough. Yes, here I told us that pressure equals the force over area. Now remember I said weight the other time, so because force or weight they mean the same thing. Don't worry about that. Now the pressure is force or weight over area. So can you see force here? Force and weight. So the pressure can be weight over area. So going back to that question now, so we have our pressure to be force over area. So here all we need to do is to know the weight of all of this water. If you know the weight, oh good. Rebecca, question? Yes, I'm listening. You want to type?
I was just wondering where question 5, where these questions are. I can only find questions 1 to 4 in the learning materials.
Oh, question. Okay, you can't find this question in the learning materials.
Yeah, I don't know where they are.
Oh, that may be a mistake on my part. But I will check. But if you check the blackboard, because I think I gave you less practice question during the study week, and I've added more onto the blackboard. But if it is missing in blackboard, Maybe there's a mistake somewhere, but I think I added some of them on practice question on Blackboard. Maybe you can't find it.
Okay, I was looking in the revision folder. I'll have it.
Oh,
Thank you.
Good. And I can check. I'll also check and see if it is missing. I will add it to the practice question. But whatever you have on the Blackboard is fine for the exam, and the practice and the books and again, don't forget I will talk about that when we get to the end of this revision. Now, so we need to know the weight of the water. If we know the weight of the water, then the area is straightforward. Area is 1 multiplied by 1. It's 1 meter square. So area is straightforward. We do not have any problem with the area. But what we need to know is how do we know the weight of this water? And don't forget, we'll be giving the density of water. And if we give it the density of water, you could see something is coming out. Something is telling me something about that. I can see mass coming out. If I know the volume, and I know the density, I can get the mass of the water. And if I know the mass of the water, I can get the weight of the water. Because the weight has a relationship with the mass. According to the formula sheet, the relationship is that weight equals mass multiplied by acceleration due to gravity. Welcome, Iska. I can see you joining the session. So now let's look at how we're going to solve this. Let me change my pen. Now here, so I'm trying to explain that we need to know, we want to find the pressure at the bottom of the tank, and I said the pressure equals weight over area. I will write this in full so that we can understand what I'm saying. Area and then weight. So if you know the weight of the water, so we can find the pressure at the bottom of the tank. So how do we know the weight of the water? Now I think you should follow me now. Now, pressure exerted by the water equals weight of the water divided by base area. That is what I've just mentioned. And Becky, if you follow me on this solution, I think you might not need you might not need to worry about the question, because I think this I will try and make sure that it is clear here. And now pressure by water equals mass of the water. Now here, weight of the water. Now because here I said weight of the water. Now this is going to change to mass of the water multiplied by acceleration due to gravity. Because if you want to get the weight equals mass multiplied by acceleration due to gravity. All of this will be given to you in the formula sheet and divided by the base area. I've not changed anything. I have rewritten this. I have rewritten the weight of water as mass of water multiplied by acceleration due to gravity. And again, let's move forward. We said earlier that our density equals mass over volume. What I'm trying to do now is to find out how do I replace this. Because I know the base area. I know the base area is 1 multiplied by 1. If you look at this again, the base area is 1 multiplied by 1. So I know this. That's not a problem. But what I'm trying to find out is the weight of the water. Now we know that mass, acceleration due to gravity, and I've been given acceleration due to gravity in the question. I've been told that acceleration due to gravity is 9.8 meter per second square. And then what I really need to know now, the missing value here is the mass of water. So, and I remember that my density equals mass over volume. So, I know my density has been given to me, then you can see my mass is coming out. Then volume also is also very easy to get, because from the dimension here, I can say my volume is length multiplied by breadth multiplied by height. So my volume is length multiplied by height multiplied by length multiplied by breadth multiplied by height. I get the volume. Volume is not a problem for us to get. So we get the volume, and after that we can now say our mass of water equals density of water multiplied by volume of water. We know that the volume of water is length, breadth, height, all of them multiplied together. We have the volume to be 25 meter cube. So we have that. We know the density, then the mass is already known. So we know the mass of water will now be the density of water multiplied by the volume. So we know that the mass of water is equals to 25,000 kilograms. Now I really want you to pay attention to this question, not because of the exam, but because of what you do every time in your place of work. Now, you handle a lot of mass, you handle a lot of materials that sometimes you only know the volume, but you must be able to convert the volume to mass, because in labeling, for example, you may be talking in mass, or your customer may be asking you, okay, I want you to produce 25,000 kilograms of this for me. But when you are getting your raw material, you get your raw material in volume. Now the conversion is very important. For example, if you want to do your nutritional information for products, some of the ingredients will be in volume, some of them will be in mass, in kilogram, in gram, some of them will be in meter cube, some of them, so you have different units. So you must be able to convert them. Excuse me. So you must be able to convert them, bring them together, like you can talk in the same language, and you don't need to worry too much about this. All you need to know is this formula: density equals mass over volume. If you remember this formula that says density equals mass over volume, you are fine. Know the density of the product you are talking about. No, if you know the density of the product you are talking about, you can talk in mass, you can talk in volume for that same product. So let's take note of that. So we've converted the volume of the water now to kilogram. So now we know the acceleration due to gravity is 9.8. So all we just need to do is to get the weight, and the weight is the mass multiplied by acceleration due to gravity, and then divided by the base area. The base area is 1. So the pressure the pressure exerted by that water is this: 245,250 Newton per meter square. Now, so take note of this. So this is the pressure exerted by the water. Now, this can be applicable in the industry as well. You want to look at, you want to design your factory floor. You look at the tank you are bringing in. Then the very first thing you want to ask yourself is that what is the mass of that, what is the weight of that tank, and then what is the weight of the material you are going to add to it. Now, when you are working, when you are doing your calculation, you want to assume the maximum scenario when it is full. When it is full, what will be the total weight? The total weight of the material inside, the total weight of the tank. Then you can actually talk to you can actually say, okay, now this is going to be the overall pressure that is going to be exerted by this tank in the factory. So you can design appropriate base for, although most of these you may not know where your career will lead you to. You might be talking about factory design in the future, and these are some of the little components, small components that will be very relevant. Knowing the pressure exerted by a piece of equipment on the factory floor, so you can design appropriate factory floor. This might even be relevant in job interviews. If you are thinking of changing jobs and you are moving towards designing, engineering, and so on and so forth. These are little things that are very, very relevant. And our understanding now will go a long way to help us to handle the situation better. So I know this is a lot of calculation involved. So I will quickly go by it again before I ask the question, do you understand? So what I really want us to do here is to find the pressure exerted by the water. And I said, you need to know that your pressure in the formula sheet is weight over area. Area, no problem. 1 multiplied by 1 meter square. We know that. Then the question is, how do we know the weight? Now, this question, it is an academic question. If it's an industrial question, I need to give you the weight of the tank as well. But my interest here is determine the pressure exerted by, let me see, what is the pressure at the bottom of the large tank of water? So I'm interested in the pressure exerted by the water at the bottom of the tank, not on the surface, not on the surface on the factory floor, but at the bottom of the large tank. So I'm interested in the pressure exerted by water. So all I need to know is the mass of that water, the weight of that water. If I know the weight of that water, then I can say that weight of the water divided by area, then I have my pressure. Now the why this is a problem, why this is a question is that I didn't give you the weight of water as that simple. No, it's not that simple. Instead of giving you the weight of water, I gave you the density of water. Then from there, you need to know that, okay, if I've given you the density of water, and then you know that your density equals mass over volume, and I've given you the volume as well. So the volume is given to us 1 multiplied by 1 multiplied by 25, that is the volume. So if you know that your density equals mass over volume, then you can actually get your mass out of that, because you know the density, you know the volume. So once you get your mass, then all you need to do is to multiply your mass by acceleration due to gravity, 9.8, then you have your weight. So your weight divided by area is the pressure. Any question? If you understand this, you can put on a smiley face. Or if you want to ask question, please. If you understand, or if you think, oh, you understand, when you go by it again. Smiley face, please. Lavender, thank you. Rick, thank you. Rebecca, do you understand? Good. Maria, are you there? Okay. Oh, good. Thank you. Thank you. Thank you. So I think this is the best time to say let's have a break of 5 minutes. Let's have some water. Okay. Do you agree with me? Okay, let's just get some water. Then after that, when we come back, we'll continue with steady state materials. Now let's come back by 14:30. Okay, we'll start again by Rick is having some nice food over there. So we start again by 14:30. Okay. Thank you. Hello, welcome back, everyone. Good. So, Chris is back. Maria is back, thank you. Rick is back. Tim, are you there? Okay, Tim is back. Good, good, good. Tiska, are you there? Or somebody is asking questions? What? Oh, good. That's perfect. Now we continue now on the. Oh, good. That's fine. What we'll do now, we'll look at the steady state overall material balance. Now, what we'll be doing here, I'll go straight to the calculations, to what I think will be of benefit to everybody. So we know it's important for control of food processing, amount of material that we need for the products, right from the scratch, without even manufacture, without the actual production. You can tell this is the amount of raw material you will need, and it can also help us in managing waste. So these are the things we know. So we'll go straight to the point. Now, mass balance, we know what is coming out is what is going in equals what is coming out, and if there's any accumulation in between there, we know we have the accumulation. So we know that our input equals accumulation plus output. And we also talk about mass flowing at any point in the system. Now, because in food industry, we do not have this batch process. We have a continuous operation. We have a flow, a continuous process. So it's not, in the past, we have batch operation, but now we talk about flow process, a continuous process. So because of that, we're talking about flow rate. So at every point in time, the mass flowing at every point in time is assumed to be constant for a steady state. Now, property of fluid in the system is also assumed to be constant. Transfer of work and heat also assumed to be at constant rate. Now, everything that all that we are talking about is that input and output at every point in time will be the same thing for a steady state system. So these are just simple theories behind the steady state operations. But we are going to be interested in the mass balance. The summation of the mass coming in equals the mass going out. And this specific example, you have a scenario whereby two components are going into this process, and then we have the product. Then we could express every second the mass of A of a compound, and then mass of B of a compound goes into the process, and the total feed per second. Now, if MA is going to the process, if MA and MB are going to the process, that tells us that the total feed per second is going to be summation of the mass of the total of the masses of the mass of A and mass of B going to the system. Now, so that brings us into the mass fraction. Now, a mass fraction of a component will be the mass of that component divided by the mass of everything. If there are two components like we have there, now mass fraction of A equals the mass of, it's going to be mass fraction of A is going to be mass of A divided by mass of everything. Now this is the total mass. So the total mass is the denominator. The mass fraction that we are interested in is the one in the numerator. So mass fraction of A will be the mass of A all over total mass, then everything. So take note of that. So total mass, it can now in a scenario whereby we have three components. Don't forget, it's going to be all the three components, and this can be done for each of those components. We could calculate the mass fraction for each of the components. Let's look at an example on how to do that. And I mentioned during the study week as well that the summation of your mass fraction, if you add them together, it must give you one. Now this can help us if it comes out in the exam. This can be a quick way of checking whether you've done it right or not. So your mass fraction, if you add them together, if you add your mass fraction, all of them, if you calculated the mass fraction for each individual component, if you add them together, you will get 1. And let's look at an example. Now, a feed to a mixer, a feed to a mixer is consists of 17 kilogram protein, 20 kilogram fat, and 60 kilogram water. Express the composition of the feed in mass fraction. Now, a feed to a mixing equipment, we have 17 kilogram of protein, 20 kilogram of fat, 50 kilogram of water. Now, we want to express the composition in mass fraction. Let's look at how we're going to do that. Now, I know some of you have already done this. As we are talking now, you know that the very first thing you need to do is to add them together. What is the total mass? The total mass, as I could see from here, is 97, if I could add right. So the total mass is 97. So if you add this together, it will be 97. So the mass fraction of protein will just be 17 divided by 97. The mass fraction of fat will be 20 divided by 97. And the mass fraction of water will be 60 divided by 97. It's a very simple question to handle. Sorry, let me change my. So let's look at that together. So the mass fraction of, now if total mass is, we've already calculated total mass together, then the mass fraction of protein will be the mass of protein divided by mass of everything. So we have this as mass fraction of protein. Similarly for fat, we have this. Similarly for water, we have this. If you add them together, you will get 1. If you add them together, you will get 1. Summation, adding them together, you will get 1 for mass fraction. Okay, I think this is straightforward. If otherwise, please ask. This straightforward? Yes, yes. Good. Smiley face? Yes. That could be way of hand. Yes, good. Good. Thank you. Good. 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 So let's move forward to more complex one. Now overall mass balance. Now overall mass balance is saying, looking at the mass of everything. Then you can also talk about components, like the module coursework, the salt, fat, sugar question. So when you're talking about the overall, everything, all the mass of the product, the mass of the material. When you're talking about components, when you're dealing with the salt question, you focus on salt. When you're dealing with a sugar question, you focus on sugar. I think the best way of addressing questions such as this is to have an example. Let's look at an example. Now here we have component of protein in A, component of protein in B, component of protein in D, component of protein in C. Now, if we are saying there's no mass, there's no loss of mass, what comes in is what comes out, all we are saying is that if this goes in, A is the one going in, B is also going in, C and D are coming out. Look at the direction of the arrow. Okay, look at the direction of the arrow. B going in, A going in, C, D coming out. Now, what we are saying is that when you mix B and A and B together, and you get C and D, now the protein in A and B must equal to the protein in C and D. Now, the protein that you have in your A and B must give us the total protein that we have in C and D. That is what component mass balance is talking about. Now, this is what I've just said. Now, the mass fraction, the mass of protein in A, mass of protein in B, mass of protein in C, mass of protein in D, you could see this equality sign. So if you add these two together, it must give you the mass of protein in C and D. And this can be done for every other component. It can be done for fat in A, in B, in the raw material and in the product. It can also be done for anything you are interested in that product. So we could see the application of this particular aspect in that module coursework. So that module coursework is something I want you to pay attention to. Understand how it works. For those who missed the question, I gave you the feedback. So understand how it works. Understand how you can solve that problem. Now, another example here is we have this already in our I will just explain this. Now the question is determine the respective masses of 10% and 50% sugar solution, which must be mixed together to prepare 100 kilogram of 22% sugar solution. Somebody has a question about not getting how to get the third equation, so I'm going to explain that now. So you have A. Now we do not have A and B. We gave it the name. You can give it any name you want to give it. You can say S and Y. You can say whatever name. Just be sure. Just ensure that you are consistent, and make sure that you are not giving a name that will make your reader to confuse it with another thing. For example, I could say X. I could say X using the first letter S sugar. But if I use the first letter S sugar here, that will be confusing. So it's always good to use a neutral letter that you think will not affect the understanding of your solution. So A and B will be perfect. Now we say determine the respect. Now we say one is A. You can say this is A and this is B, or the other way around. All you need to do is just to be sure that you are consistent. The question says, what is the mass of A and B? They ask, that's the question. That will be mixed together to give us 100 kilogram, but now the interest is 22% sugar. One is having 10, one is having 50. How must we mix them together to give us 22% sugar? That is just the question, without having to do trial and error. So using your mass balance knowledge, you could tell me what this will be. And this is the same solution that you apply to the module coursework. It is the same. It is the same solution. And we did this during the study week, which I believe you can apply to the module coursework. So I want us to pay attention now. How we are going to do this. Now, the very first thing you want to ask yourself is, what is the overall material balance? Overall material balance, as I can see from here, is that I can see my let me just change this. Yes, I can see my A, one component going in. I can see my B, the other component going in. We gave that name because we've been given two components here. One is 10%, the other is 5%. So I can see my A going in, I can see my B going in, and I can see 100 kilogram coming out. Now this is talking about the overall, the mass level. The overall mass level. This is not a sugar level. So overall, I will say A plus B equals 100. That's the first thing I will write. That is overall material balance. Now, going to the component material balance. The interest here is sugar level. One is 10%, one is 50%, and the other one is 22%. So 10% of A is sugar. Okay? 50% of B is sugar. And 22% of the product is sugar. So talking in sugar language now, in sugar terms, in sugar level. So I've gotten two equations already. A plus B equals 100. Then 10% of A plus 50% of B equals 22% of 100. That is at sugar level. Let's look at what we have here. Now, material balance based on sugar level: 10% in A, 50% in B, 10% in A, 50% in B equals 22% in 100 kilogram. That is at sugar level. Now, to make it simple, I need to convert my percentage to numbers. 0.1 multiplied by A, 0.5 multiplied by B equals 22%, which is 0.22 multiplied by 100. So I have this as equation 1. So it doesn't really matter. Anyone can be equation 1. The overall material balance can be equation 1. It doesn't matter. The order of the equation doesn't really matter here, but the order of solving your problem, because I have an encounter with a very good student. She made a mistake. He or she made a mistake. I won't say he or she now. He or she made a mistake in the order of presentation, and it was not clear to me. But in terms of naming your equation, it doesn't really matter. Any order is fine. But as you start solving them, it has to be clear. I will explain what I mean by that. Now, so here, let me get rid of this. So here, I have A plus B equals 100. That is the overall. A plus B equals 100. That's the overall material balance. And I call that equation 2. We have the sugar level equation. The sugar level equation is 10% of A is sugar, and 50% of B is also sugar, and 22% of the product is also sugar. So this is talking about sugar level equation. So this is talking about overall A-level equation. Now we have two equations. Now the question, we have two equations, we have two unknowns. The question now is, how do we solve them? We need to use simultaneous equations, methods of solving simultaneous equations to solve this problem. And it is the same method. Once you understand how to solve simultaneous equation, you can use your approach. It doesn't matter. All you need to do is just to make sure that I can follow your solutions. Anybody can follow your solution with that assumption, Moses should know this, or my examiner should know this. No, you need to make it clear for anybody to understand your equation. Now, you could use any methods. You could use substitution method, you could use elimination method, whatever method you think is convenient for you in solving simultaneous equation, you should use. Now let's try and see what method I use here. Now, I'm using substitution method. I said from equation 2, my A will be 100 minus B. You could see 100, you could see A equals 100. Now this B is being moved to the other side, so it now is now minus B. That is my equation 3. Okay, that is my equation 3. Now, I have gotten equation 3 from equation 2. So, I cannot use equation 3 in 2 again. I can only use it in equation 1. So, because this 3 is another... Oh, nice. I think the question is trying... Okay, Maria? Question? Oh, Maria. Good. Okay. So A plus... no. Maria, here, we do not have D. There's not... We only have a product. We only have a product. Now, we do not have D. So, in this particular problem, no D. D is not given to us. We only say C because we've been told which must be mixed to prepare 100 kilogram of 20% sugar solution. So that's the product. So D is not going to be here. Now let me see the next question. So we do not have C plus D. We only have C. Okay. Yeah. So sorry, Maria, you've been typing some questions, but I couldn't. I'm just seeing them now because I focus on the explanation. So when you put up your hand, I will understand. Good. Okay, I will explain again, Maria. Now, I will explain again. Let me see. You have in your product, let me see if I can get something up. So you have A plus B. We've said that this is going to be 100. This is overall material balance. Okay. Now, when you are solving the problem, you can leave the unit out. Don't worry about the unit. But when you get the final answer, you can put the final answer. You can put the unit in final answer so that you don't have many complexities, a lot of things to worry about. Forget about the unit when you are solving the problem. Now, this is overall. At individual, if I can remember this, I'm not sure if I can remember it. Let me see if I can. At individual, we have 10% and 50%. So at individual level, 10% is 0.1. If you agree with me, I can write my 10% as 0.1. 10% of A and 50% of B. I can write my 50% as 0.5. Okay. This is sugar. This is sugar. It must give me 22% of sugar in the product, which is 0.22 multiplied by 100. That's the product. Now that shows that 0.1 A plus 0.5 B must give me 22. Okay, so 22. Now this is talking at sugar level. Now I know you understand all of this. Now from here I can say this is 1, this is 2. From equation 1 I can say that my A equals 100 minus b. From 1, I can say this. So I will now call this one equation 3. I'll call that equation. Now the method I'm using here is called substitution methods. There are several methods that I can use, but somebody is, I think one of you suggested that I should be using, I should use one method, so that it's better to re-explain that one method again rather than using another method. So it's because people will be confused. So I will use the same method. I will stick to this method so that I can be consistent in terms of my explanation, so that I'm not confusing you. So here I have the equation 3. Now have a look at this. This one, a plus b equals 100. I got this equation 3 from there. So when I'm going to substitute, when I'm going to use equation 3, I cannot go back to equation 1 and use it. I can only use this in equation 2. So we have 1, 2, 3. So look at this. I have my a to be this. Please everybody follow. I have my a to be this. So all I need to do is to go back to equation 2. I can say use this in equation 2. So when I use this in equation 2, I will now have 100 minus b as a substitute for a in this place. So if I put that as a substitute for a, this 0.1 will be multiplying everything. So this 0.1 will be multiplying everything. What we are trying to do here is to try and make sure that we have a single equation that will have just one unknown. Because in equation 1, we have equation 1, there are two unknowns, a and b. Equation 2, there are two unknowns, a and b. Equation 3, there are two unknowns, a and b. So how do we solve it? So we are trying to manipulate the equation such a way that we can have only one unknown in the equation. If you have only one unknown in the equation, one unknown, whether a or b, we can now say, okay, it's easier for us to solve that. So if you have this as equation 3, let's go back to this. Now if you come back here, now look at this. This is what we now. If you look at and I said, look at this is what I've explained in the previous slide. This is equation 3, 100 minus b, and I said put equation 3 in equation 1. My equation 1 now here is this. This is equation 1. If you look at my explanation here, it is equation 2 in this place. It doesn't matter. The other it doesn't matter. It is equation 2 in this, and what I'm just working here. So put it in equation 2. Now the other does not really matter. We are the one giving it a name. 1, 2. If you like, you can call it equation X, equation Y, equation Z, equation 1000, equation 1001. It doesn't really matter. So just make sure that you are consistent. So and I said put equation 3. This equation 3. This is equation 3. Put that in 1. Let me change back to this. Put that in 1. This one, equation 3. This is equation 3. Put that in 1. If you put that in 1, this is 1. Go back to 1. This is 1. Okay. So look at it. We have A. A equals 100 minus B. You know, this is what I'm talking about. If I've removed kilogram, this makes it simpler. So if you work without the units, it's fine for me. Make it simpler for yourself. So 100 minus B, put that wherever you see A in equation 1. So I can see my A here. Okay. So 0.1 is there. Nothing is moving that. It's there. Multiply by 100 minus B. That is where I have my A. Okay. Plus, don't forget, equation 1, I have to write everything in fully. I have to write everything full. I can't just stop there. I need to continue. 0.1. This is 0.1. 100 minus B. That is A. Don't forget, it's multiplying everything. That's why I need to put in brackets. Plus 0.5B, which is this one, equals, can you see that? 200 kilograms. Now, if you open this bracket, okay, here, if you open this bracket here, you'll be having 0.1 multiplied by 100, that will be 10, minus 0.1 multiplied by B, that will be 0.1B, minus 0.1B, plus, now I finished with the bracket, I finish with the bracket, plus 0.5b. Can you see that? Can you see that? 0.5b equals 22. Now, can I ask now, Maria, do you understand up to that point? Maria, are you there? Good. So if you follow that, so now you have 22 now. Now look at it now. Here we've been able, all of us together as a class, we've been able to ensure that in that single equation we only have b as the unknown. We only have b. That is our target. Look at it. We only have b as the unknown. If you look at that, we only have b as the unknown. So 10. Don't forget that 10, don't tell me you don't know where it's coming from. It's coming from 0.1 multiplied by 100. Minus 0.1b is coming from 0.1 multiplied by b. So here we have minus 0.1b, we have plus 0.5b. So you could see common elements. You could see common elements now that we can put together. So minus 0.1b plus 0.5b. Now add them together. This is like saying I have negative 0.1b, I have positive 0.5b. Now, if you take your calculator, 0.5 minus 0.1, or if you do it the other way around, you say minus 0.1 plus 0.5, you will definitely get 0.4b. Okay, you will get 0.4b. Now, if you have your 0.4b, then as this 0.4b is talking about the summation of these two. Okay, your 0.4b is talking about summation of these two. It's talking about this one. Okay, your 0.4b is talking about the summation of these two here. So that is where you have your 0.4b. Now you have this now. Now 10, you can see 10 and 22, they are families. You need to take 10 to the other side. So you are left with 0.4b here, then 22. By the time this 10 crosses this equality sign, it turns to negative. That is why you have minus 10. So 0.4b will equals to 12 kilogram. So 0.4b equals 12 kilogram. Our interest is b, not 0.4b. Our interest is b. 0.4b equals 12. Equals 12. Our interest is b. So our interest will now be b, which is going to be equals to 12 divided by 0.4. Now, if you divide your 12 by 0.4, you will definitely be getting 30 kilogram. So our answer for B will be 30 kilogram. Now, you've gotten your B. Do you all understand up to this point? Maria? Do you understand up to this point? I need another yes, please. Good. Maria? Oh, great. Thank you. So, you have your B now. Now, then all you need to do now is to use any of the equation. But if I were you, I will use the simple equation. I will not use the complex one. I will use the simple one. I will use A plus B equals 100. I can use any of those equations to get my A. But I will go for the simple one, A plus B equals 100. If I use A plus B equals 100, and you know that your B is 30, so your A will definitely be 70. Okay, you don't need to show me how you get this. I know this is the hard work. You've done the hard work here. So I will know definitely by stating that on using equation 2, your A will be 70. Because A plus 30 equals 100. So, okay, Rebecca, that's fine. Thank you. So the video will be available maybe probably tomorrow. Thank you. So do you understand that now? So you have your A. Okay? Maria, do you understand that? Good. Good, thank you. So that's that. And the same thing. That tells us that we need 70 kilogram of 10% sugar solution and 30 kilogram of 50% sugar solution to prepare 100 kilogram of 22% sugar solution. So that is that. Now the same process, the same method for this as well. Now a meat processing plant is producing minced meat, which must contain 15% fat. If this is to be made up from boneless cow beef with 23% of fat, and from boneless bull beef with 5% of fat, what are the proportions in which this should be mixed? This is the same thing with sugar question. It's the same thing. We want to make a minced meat, and that must be 50%. Then now, but here we are not giving the mass, so we can assume. Okay, let's assume that the total mass, the interest. You know, if you are not giving the mass, it's always good to go for 100 gram, 100 kilogram, or 100 is good. So because it's very easy to do that. So we go for 100. If you are solving this problem, we want to go for 100. So we know that we want to have A and B. Let's say A is, let me see, I think I've given that now. I say A here is cow beef, and that has 23% fat. B is the bull beef with 5%. Our minced meat must have 15% fat. So how do we mix the two together in such a way that the fat we are going to have in the overall product is 15%? So we've assumed that the product is 100 kilogram. That is the C. So all we need to do is to say, okay, now A is cow beef, 23% fat. B, boneless, 5%. Our product, 15%. So overall material balance is this. Is the first one. That's always your first one. The second one is your fat material balance. Now, don't worry about A, B, B, C, C. It is the same thing. I'm only saying 23% of A, 5% of B, 15% of the final product. That's what it's saying. If you look at this, 23%, 5%, 15%. 23% of A is fat, 5% of B is fat, and 15% of the product is fat. Then that's our equation 2. So equation 2 is known, equation 1 is known. Then using substitution method as well. So I can say from equation 1, B equals 100 minus A. From here, I can say B equals 100 minus A. Substituting. Now here I did not say A, I said B. So I want to make B the subject of the formula. So you can use any of the two. So going here I left my 0.3A as it is, 0.05. Now my B is now 100 minus A. You can see that now, 100 minus A will give us 15. So which is the second part. Because see, this is what I'm using here. I'm using this equation. Let me change my pen. So I'm using this one. Sorry, I'm using this one here. If you look at it, it's the same. It's the same. Sorry, here. If you look at this one. So 0.23A, 0.5B. Now my B equals 100 minus A. 100 minus A. You could see that equals 15. So 0.23A. Now 0.05 multiplied by 100, 5. 0.05 multiplied by minus A, this equals to minus 0.05A. Now this is going to give me 15. Okay, and we have that. So we have 0.23A. Now I can see the family of A's. I can see the families of A I can bring together. So 0.23A minus 0.05. Then 15 and 5, they are family. Then I take this one to the other side. That equals to 15 minus 5. Then 0.23 minus 0.05. Use a calculator for this. You have 0.18A. Then 15 minus 5. I don't need a calculator for that. That is 10. Then my A will now be 10 divided by 0.18. So I have my A to be this. So I've gotten my A. All I need now to do is to use equation 1, the simple one, to get my B. Put 55.6 here. I can get my B to be 100 minus A. So when I have 100 minus A, so you can see 55.6 is A. B is what I'm looking for now, 100. Then B will now be 100 minus 55.6. Now my B will be this. Now here, in the first one, we computed B first in the sugar question. Now here in the meat question, we computed A first. It doesn't matter. But if anyone you are computing first, make sure you state it clearly. So it is the same principle. Oh, question? Lavender, yes? Now, example with 3 components. Yes, it's possible, but I do not want to stress you too much. I want to be a nice teacher. So if I give you an example with 3 components, that will be a lot of work. Yes. Yes, example with 3 components is possible. If this is something you are interested, or if you think that this is very relevant to what you do in your factory, or maybe a lot of products, a lot of raw materials coming in, and you think you need my help, we can sit together and we can solve them together in real life. Apply this into real life. But this is just to give you the basic understanding of material balance. But if I give that to the class, I know I will be having a lot of questions. Okay. Good. So we'll go now. Question again? Yeah, I'm listening. Can we use the same approach? Yes, you can use the same approach. Yes, yes, you can use the same approach. Let me see. I'm thinking. Okay, is there any possible question that requires to combine 2 raw materials, e.g. A and B, that constitute different content, fast to produce? Yeah, maybe I'm not really sure if I understand your question, but you can definitely use the same approach. You can definitely use the same approach to solve your question. Yes. You can definitely use the same approach to solve the same approach, the same principle. Yes, it's possible. Yes. Yes. I'm not sure if I've answered the question, Yavenda. Sorry, Piska. Have I answered your question? Piska, have I answered your question? Piska? Piska? Are you there? Yeah, good. I think I'm having I'm not sure if I get that question. Somebody's typing something? Oh, good. So let's go back. I think I'm having an issue with my material. Oh, good. It's back now. It's back. I'm having an issue with my material. Now, let's go back. Yeah, yes, we've covered that. Yes, we've covered that. Now, let me see. Somebody's changing the? Okay, it's fine now. I think I'm having issues with my Blackboard. Yeah, my Collaborate. I think if you are touching, don't change the page number, please. If you have the, let me see. If you have the permission to change the page, don't change the page. The page is just flowing from one to the other. Oh, good. It's stable now. Can you hear me now? Yeah, good. So that's fine. Okay, that's fine, team. We'll try and record this. Can you, now, I am sorry. Can we do something, please? I think the system is not stable now. The system is not stable. Can we log off? Can we all log off and log in back in the next? Let's log in back by. The system is not stable. I don't know what's going on. Something is wrong with the system. Can we log in back by? I'm having issue with my system here. Can we log in back by 20 past? 20 past? Okay. Let's log out. Everybody, let's log out. Let's log out so I can save what I've done. Let's log out. Let's leave the class. Close the collaborate from your hand. Let's close collaborate from your hand so that when you leave the class, by closing the collaborate from your hand, I will. Thank you. Good. So I will. Let's log in by. Yes. Thank you. Thank you. Thank you. I'll also close here and then log in back. Thank you. Yabenda, if you can leave the class. Good.